Data flow. So the first type of data flow we will look at is the simplest. In the simplest mode of data flow, you can see it as a one-way street. So where the data can be sent from to only one direction at a time. So we have two points from point A to point B. We want to send the data. Now, how are we able to send the data? In simplest mode, here only point A can send a data at a time, or only point B can send a data at a time. So, for example, our basic example is being given here is the keyboard. So the keyboard here, the simplest means, for example, the keyboard, the only thing it can do is to introduce input to the system, and the monitor to bring out output. So in the entire duplex or simplest mode, you can actually use one route, just one route. So if it is going, it is only meant for going. If it is coming, it's only meant for coming. So we have a network there, point A to point B. There is no way you can send from point B to point A. The network we've established is simplest, meaning only point A can transmit. Point B can't revert. So that's and the simplest data flow mode. Now they have duplex one. Yes.
Hello, sir.
Yes.
Please, can you give us a scenario?
Okay, so the scenario is um so one scenario they gave us here is the keyboard one. So you see, they connect the network between your keyboard and your system unit. So there is no way you can actually send something to your keyboard. Your keyboard just send input to you, and that's all. You get it? So it's just one way thing.
Okay.
Yes. So for monitors, the monitor just output. So that's the network the monitor has with the system unit, or the keyboard has with the system unit. So there's no way the system unit can send something to the keyboard. Only the keyboard sends something to the system unit. So that's a one-way simplest mode. Okay, they have,
Sir,
yes.
please, what about the servers in this big company? The servers, I'm asking, I don't know whether if I'm right, whether if servers also does this in a simplest way, because with
Okay,
what I know, I think servers mostly send information to the users, and users cannot send messages to them, or
it depends. It depends on the organization, yes. So when you have an organization such as let's say financial institutions, the clients and the servers, they both communicate. The server to the client will request for individual's bank account, will send a request, and the server will bring it. So you see, they both communicate there. So it depends.
okay.
Yes, it depends. Now in half duplex mode. In a half duplex mode, transmission can be done in both ways, but not the same time. So for example, there is this path, or there's this transmission you are actually doing. So this path is actually, so point A, point B, the medium between point A, point B is half duplex mode, meaning point A can send something to point B, and point B can also send something to point A, but they cannot do the same thing at the same time. If point A wants to send something to point B, meaning point B has to wait for point A to send it. When point A is done, then point B can also send it back to point A. Please, do you get it? Right. The next one is the full duplex mode. In this full duplex mode, what's meaning is, in fact, both ways can actually send and receive. For example, our daily phone calls we make is in full duplex mode. So I can call someone, the person will be talking and I'll be talking. Can both send and receive. So I can call someone, the person asks, how are you? I'm fine. So, or either if there is even an argument, the person will be talking and you'll be talking at the same time simultaneously. You can send, transmit, send and receive at the same time. That's termed as the full duplex mode. Please, any question with the data flow? Okay. Now, network distribution or network links. Now, the distributed processes, we actually learned this last week where we realized we have the server client, we have the peer-to-peer. So this here, the distributed one is whereby, so we have the server client one. So whereby we have one there that distribute or is responsible for sharing among other clients. So we have a workstation there that's actually given to the other clients. Now, what are the criteria a network must be able to meet to be considered a good network? What criteria a network must be able to meet to be considered a good network? We are going to look at the three most important criteria a network must at least possess to be considered a good network. 1, the performance. 2, reliability. And 3, security of the network. So let's take performance. Now, in performance, it can be measured in so many ways. We have the transit time, we have the response time, we have the throughput, we have the delay. Now, what is a transit time in a performance? The transit time is the amount of time required for a message to travel from one device to another. So if the performance is being measured by 1, the transit time, that's the amount of time for a message to reach one device. So we want to transfer from point A to point B. How long does it take for a message to reach point B if you are sending from point A? That's the transit time. So the transit time can also be used to determine the performance. Is it either fast or slow? The next one is the response time. The response time is the time it takes for you to get a response when you make an inquiry. So let's say the ones we just talked about, a server and its client. So the client make a request to, we are saying the server should give us the remaining amount in a certain bank account for a particular person. So we send the request. How long does it take for we to get a response? That one is termed as response time. So the response time, the transit time, can also be used to measure the performance of a network you've created. Does it take longer to get response? Or does it take long time for you to send a message from the client to the server or from one point to another. If it's fast, you know how your network is actually doing with the response time and the transit time. Now, the performance of a network depends on a number of factors. One, it includes the number of users using that particular network, the transmission medium, the capabilities of the connected hardware, and the efficiency of the software you are using. So for you to measure the performance of a network, when we are coming to measure the transit time, we are coming to measure the response time. But one thing we will base on it, the factors that are affecting these are the number of users on this network. If we have more number of users, there's likelihood our transit time is going to decrease, or our response time. Well, you can actually see that when you visit a website that's highly demand, sometimes it takes a lot of time to respond to you. So whenever you type that link, you see it takes long time before it comes, meaning there's much pressure on it and people are requesting a lot from the server. I mean, the number of users is affecting the server. The next one is the type of transmission medium. Is it using the wireless one, the signal, or using the twisted cable or the other cables? The medium is also a factor in measuring the performance of a network. Now, the capabilities of the connected hardware. Maybe the devices you've used in your connectivity has very slow RAM or slow speed, low RAM, low hard disk, therefore making it computing very slow. It also affects the performance of your network. Now, the efficiency of the software you are using. Now, what software are you using? Are you using a network software, or are you using any other software? The software you are using, how efficient is that software? You need to also assess the efficiency of that software to be able to fully understand the performance of your network. The next thing we can evaluate our network performance is using throughput and delay. What is a throughput? So here is, we often need more throughput and delay. However, these criteria are contra. So if you try to send more data to the network, so throughput is how often does data pass it through our network. So if there's so much pressure on our network, so it passes through just in any seconds, then we send, there is high probability that the delay, so there might be congestion in the medium you are sending through, so in the channel. So if you are sending through twisted cable, you can see as more demand, as you are pushing more demand through that channel, it becomes jammed. So if you visit a website that you have to access resources and more people are visiting at the same time, you see it has become jammed. It can't load, and it will even tell you that site is down, error 404, and a whole lot of things. So how often we send things through the network also affects the performance of the network. But all these, it will depend on the capabilities of your hard disk or of your hardware, and the efficiency of your software, and the transmission medium you are using. All these will depend on that. If you are using a robust system, then you should be able to push more more medium through it, and it should be able to work just fine. Please, any question with the performance?
Yes, sir.
Okay.
So let's say in a scenario whereby all these factors are constant, or let's say they are all equal, but can there be a scenario where the networker, the one who developed it, have to do something to it that can make it perform faster or perform lesser? Or maybe let's say maybe the person is not that good. Can it affect the fact? Can it affect how speed it will go? Did you get my question?
Yes. So you are talking about the setup. If the
Yes,
person,
sir.
yes. Basically, actually, yes, it can affect it if it's not set up well. Maybe the software you are using, you have to do something before maybe it will perform, and the person don't do it or skip that process. Yes, it will affect. And let's okay, and also if the person or the technician refuses to maybe connect your cables well, it will also affect the network performance. So the setup is also important. Is also important. If you're able to set everything well, and everything is actually the same, or the sizes you wish, your network should be able to work just fine. Reliability. In addition to accuracy of delivery, network reliability is measured by the frequency of failure, the time it takes a link to recover from failure, and the network's robustness in a catastrophe. Now, for you to check the reliability of a network, how reliable is your network when it fails? How frequent does it bounce back? No, you can't say the network will perform 100% just fine. No. Sometimes it might go down, but when it goes down, how quick does it take to bounce back to its strength? Or when there is a disaster, so disaster here in terms of, let's say, light out here. Yes, so let's take light out, and when the lights come back, how long does it take for your network to come to its normal strength? So the reliability here can also be measured here. How the frequency of failure, how often does your network fails you? Does it often fails you, like let's say 10 times a day? Then there is a question mark on it. How often does it take long time to recover after it has gone down? You have to also check that. So that's the measure you can use to actually predict or detect the reliability of your network. So for example, people will say, oh, MTN is not good because when it goes down, it takes a long time to come back. Or in a day, it keeps failing. You'll be doing that, your network is gone, and your network comes. So based on that, some people can also say, oh, it's not reliable. So based on this, you can use to actually measure the reliability of your network. Please, any question on that? The next one is security.
Yes, sir.
Okay.
So with the reliability, should we say that the setup or the engineer is not right, or he's not good, or there are other ways of doing it that he didn't do it right, or I don't know, because realize this, I'm not going to do something that people would use and then will not be reliable. So what are the things that may happen or may occur that will make it not reliable? So do you get it?
Yes, I get it. Now, reliability factors comes in so many things. One, if you don't set it up well, it will keep breaking and those stuff. Two, if your hardware devices, they are not enough, or they don't have enough strength to power the medium or your network, to power the or to handle the request, it won't be reliable. It will keep on cutting or jamming. So if you have a bandwidth that's less and the number of users accessing that resource is more, you are assured that your network is going to be jamming here and there. So it also boils down to this the type of transmission, the capabilities of your hardware connectivity, and the efficiency of your network, the efficiency of the software. Yes, reliability will also boils down to that, because if you are not using the right hardware, you might be able to set up though, but it won't be reliable. Or if your technician didn't set it up well, you are also likely to experience breaks or in your network. The next one is security. Every network should have security. If you don't have security, those in hacking, those who are always sniffing around, those who are always want to take advantage of this digital era will actually come after you, because they are always exploring and exploiting. And if someone will be able to get into your organization, is through a network. Without a network, the person can't get access to your organization's resource. So in every organization network, there has to be security. Security to prevent unauthorized access to resources, to protecting the data from damage, or adding data, or unauthorized addition of data, or updating of data, breaches and data losses. So we have to implement security such as the firewalls. We will also we will dip, or we will actually get to these security features. But for now, for a network criteria, there has to be security. You have to have security as part of your network. So the performance, the reliability of your network, and the security of your network, these are the top most important things or criteria a network must be able to meet or must be able to have. So you assess the performance, the reliability, and the security of your network. Please, any question with the network criteria? Now, we have physical structures. Physical structures. Now, I'll give you an assignment here. Assignment here you are going to do is going to read about the physical structures, the type of connection. So from point 1.2, yes, 1.2.3, that's the physical structures here. We are going to learn up to bus topology. So you are going to learn up to here, this one. So the next time when we come, we are going to discuss. We are going to share our ideas on how we understood each of them. So these are the physical structures, how we can arrange a network. So we have, for example, we have the star topology, we have the mesh topology, the star topology, the bus topology. Yes, and we have the ring topology too. So read up to the ring topology. Next time we'll continue from here. So the ring topology, all the topologies that's classified as the physical structures. Please, that's your assignment. We are going to read about it. And our next meeting, we are going to have discussion. It's going to be a discussion for the first 30 minutes, but you are going to explain to us how it is done, and the advantages and the disadvantages you gain from it. Please, any question on this? I will send the reading materials to your Slack channel for you to get access to it. And you, the last time too, I sent something in the Slack channel. Let me quickly get it and show it to you. Yes, I want each of us to get familiarized with these. Let me see if I can get it. Because we will be using we will be using them for our practical. So I want us to actually know these terminologies. So there are terminologies I send in your Slack channel.
Say,
Yes.
say please, is it the one in the yellow with the yellow color?
Let me see. Uh, so I've written, take note of these terms. It's a screenshot. Okay, let me try and share something here. So as you can see from my screen, this one is in the Slack channel. Please take note of these terms too. So what is MDF, IDF, broadband, narrowband, dial up? That's when we say someone goes online or always online. So download speed, upload speed, ISP, ISDN, PSTN, ADSL, MBPS, KBPS, Ethernet, USB, modem, router. So please take note of these terms. You'll be using it a lot. You'll be using it a lot. As a network student or as a network person, you need to understand these things automatically. So when someone asks you what's an ISP, or when you say what's the download speed, or what's an upload speed, what's ISDN, what's a dial-up, or narrowband or broadband, what's the meaning of broadband, what's the meaning of narrowband, please take note of it. Yeah, we'll be using it a lot in our training. Okay, is there any question, please, before we end our session? Right. If there are no questions, thank you very much for today. Enjoy the rest of the day.